Hey there, welcome back to my channel. In this video, we're going to talk about how atoms come together to make molecules by forming chemical bonds. And just so you know, the word come together is synonymous with interact. So if any of you fellow scholars out there happen to be listening to this through a podcast app, you won't hear any background music during this discussion. All right, let's get started. Atoms are like the individual building blocks of matter. Can't really get any smaller than an atom. However, these individual atoms can interact or bond with each other in various ways to form larger units called molecules. But why do atoms even want to interact with each other? Well, it all has to do with the quest for stability. Just what does that mean? Let's consider the simplest atom out there, hydrogen. The number of protons in an atom tells us its atomic number. And if you're watching this video, you already know that the number of protons in a hydrogen atom is 1. That single proton resides in the nucleus of the hydrogen atom, and we place one electron in the highest energy level or shell around the nucleus. You may have learned that the first shell only holds a maximum of 2 electrons. Well, so adding a second electron to hydrogen would require moving it to a second energy level, which would require more energy. It's energetically more favorable to keep the first shell empty or filled. As we go up the periodic table, the number of protons increases, and thus the number of electrons also increases. This means that the higher energy levels fill up as we move across the periodic table. You can think of it like filling up a stadium row by row, where each seat represents an electron. So given that all atoms want to have a full outermost shell, they'll try to interact with other atoms in order to accomplish this goal. In the case of hydrogen, because it only has 1 electron, it'll tend to lose that single electron to get a full outer shell. When an atom loses an electron, it becomes positively charged, since there are more protons than electrons. If we look at the periodic table, we see that the noble gases are the most stable elements, which means they have the lowest energy. They are the least reactive because their outermost shells are completely full. And in some cases, like helium, the only shell they have is completely full. So the goal is for every other atom to become like the noble gases. They want to achieve a full outer shell. Now, how do atoms actually achieve this goal? There are 2 main types of bonds: ionic bonds and covalent bonds. For simplicity, let's say we have 2 hydrogen atoms that are pretty far away from each other. These 2 individual hydrogen atoms are not very stable because they both only have half of their outer shell filled. So they get closer to each other and notice that one hydrogen atom is slightly bigger than the other. Now, if the larger hydrogen gets even closer to the smaller one, it'll give that electron a big enough shove to knock it right off. This now means that the hydrogen that gave up the electron has 2 electrons in its outer shell, meaning it's happy. Now the hydrogen that received the electron has 2 electrons in its outer shell as well. This transfer of electrons from one atom to another makes ions. The hydrogen that lost an electron is now a positively charged ion, H+, and the hydrogen that gained an electron is now a negatively charged ion, H. These oppositely charged ions attract one another and form what is called an ionic bond. Ionic bonds are formed due to the electrostatic attraction between 2 oppositely charged ions. Let's take a look at another example, this time with sodium and chlorine. Sodium is a metal, and chlorine is a nonmetal. In general, metals tend to lose electrons to form positive ions, while nonmetals tend to gain electrons to form negative ions. This is due to the fact that metals typically have 1 or 2 electrons in their outer shell, which they can easily lose, whereas nonmetals often have nearly full outer shells and only need a few electrons to become stable. In the case of sodium, it has 1 electron in its outer shell and chlorine has 7. If sodium gives its 1 electron to chlorine, then they will both become stable. Sodium will become a Na+ ion and chlorine will become a Cl ion. These ions will then be held together by ionic bonds. Ionic bonds are fairly strong, but they're not as strong as covalent bonds, which leads us to our next type of bond. Covalent bonds involve the sharing of electrons between 2 atoms. Let's go back to our 2 hydrogen atoms that are far away from each other. These 2 hydrogen atoms are not very stable. Each has only 1 electron in its outer shell, so let's say that they get close to each other. You don't have to get super close, just close enough to share a pair of electrons. Now, if these 2 hydrogen atoms can share this pair of electrons, then they both have 2 electrons in their outer shells, and they're both relatively happy. A covalent bond is the electrostatic attraction between 2 atoms that are sharing 1 or more pairs of electrons. Let's take a look at another example with oxygen. Oxygen has 6 electrons in its outer shell, so it needs two more to complete its outer shell. So let's say two oxygen atoms come close to each other. They can share a pair of electrons between them. This sharing of electrons allows both atoms to achieve the coveted 8 electrons in their outer shell. Note that sometimes the sharing isn't exactly equal, but we'll talk about that in just a bit. Okay, so why don't all atoms just share electrons with each other? Why do some atoms donate and others receive? Well, atoms tend to donate or share electrons depending on their position in the periodic table and how strongly they attract electrons. This tendency to attract electrons is called electronegativity. Fluorine is the most electronegative element on the periodic table, meaning it attracts electrons more than any other element. In general, elements on the right side of the periodic table tend to be more electronegative. On the left side, you'll find the least electronegative elements. Electronegativity differences between two atoms determine whether the electrons will be shared or transferred from one atom to another. The greater the difference in electronegativity, the more likely the electron will be transferred. The smaller the difference, the more likely the electrons will be shared. If the electronegativity difference is small, then the electrons will be shared equally or almost equally between the two bonded atoms. This results in a nonpolar covalent bond. If the electronegativity difference is large, then the electrons will be shared unequally, resulting in a polar covalent bond. Let's take a look at the water molecule as an example. Water is made up of 2 hydrogen atoms and 1 oxygen atom. Since oxygen is more electronegative than hydrogen, it'll pull the electrons in the OH bonds closer to itself. Because the electrons are being pulled closer to the oxygen atom, the electrons spend more time around the oxygen atom than the hydrogen atoms. This unequal distribution of electron density makes the oxygen end of the molecule slightly negative, and the hydrogen end of the molecule slightly positive. The slightly positive hydrogen end of one water molecule is attracted to the slightly negative oxygen end of another water molecule, and these interactions hold water molecules together in liquid form. If the electronegativity difference is large enough, the electron will be transferred from one atom to another. This results in the formation of ions and ionic bonds, as we discussed earlier. So in summary, atoms want to be like the noble gases. They want to have a full outer shell of electrons. To accomplish this, atoms will either share or transfer electrons. Sharing electrons results in covalent bonds, and transferring electrons results in ionic bonds. The type of bond that forms depends on the difference in electronegativity between the two interacting atoms. I hope this video was helpful. If you have any questions, please leave them in the comment section down below. As always, thanks for watching. See you next time.